All right, so again, properties of exponents is something that it's kind of, the properties are relatively simple, but the application of it is where they try to get tricky. They give you a bunch of different stuff to deal with. So I'm going to list the properties from 5.1, show some really easy examples, and I'm going to show you just kind of what they do to make it difficult. So for starters, just what an exponent is by definition. Okay, so when we have numbers here, regular numbers, or the numbers that we typically think of, are referred to as your base numbers. And then these little numbers up here, if they're there, these powers, okay, are your exponents. And basically what exponents do are they are a shortcut for multiplying the same number over and over and over and over and over again. So this is said 2 to the 5th power. Okay, what this implies in expanded notation is 2 times 2, okay, 5 times. Now, when you're evaluating exponents, make sure you understand that I'm not multiplying 2 times 5. Okay, I'm multiplying 2 times 2, 5 times. So in this case, that would be 2 times 2 is 4. Okay, 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So make sure you're properly evaluating exponents. On your calculator, if you need to evaluate exponents, there's a couple of different buttons for this. Some calculators give you an up caret. That's typically on like the TI 30s or 32s. Okay, I like the Casio calculators. And they'll have an X with a box, or sometimes it's a box with a box. Okay, if you're ever not sure, I can kind of walk you through how your calculator does it. Some calculators have like an X to the Y button. In any case, you'll typically hit your base number, then your exponent, then hit equals, and it should give you your answer. So type in 2 to the 5th power and get 32. Anyway, that's just what an exponent is by definition. We're going to be talking about properties of exponents and how they relate. So we're going to be doing with variables and exponents and stuff like that. So the first property kind of works both ways, but any number to the 1st power is itself. And this one actually usually works backwards. So if they just give you a number and you don't see a power to it, it's implied that that's to the 1st power. So if you don't see a power, it's a 1, or any number to the 1st power is itself. Okay. Next property is anything to the 0 power is 1. It doesn't matter what you are doing, anything you take to the 0 power, the answer is just 1. Okay, and negative exponents, a negative power, negatives send things from the bottom to the top or from the top to the bottom. So x to the negative y becomes 1 over x to the y. Or vice versa. If you have 1 over x to the negative y, that becomes just x to the y. So again, negative exponents switch things from the top of a fraction. So again, because any number you would want to write as a fraction, you can just simply put it over 1. Okay, that negative exponent sends it to the bottom of the fraction. Or the other way around, if there's a negative exponent on the bottom of the fraction, it sends it to the top.
So is it basically just flipping the sign? Is that what I'm understanding?
Not necessarily flipping the sign, but whenever you see a negative exponent, it's going to flip from the top to the bottom, or from the bottom to the top. And I'll do some examples and it'll make a little more sense when you see the example. So this is like the most basic example of these properties. And I'm going to give you some more complicated examples and hopefully you'll get a better understanding of it. Okay, the last one is kind of how they're going to relate to each other. So the next major property is if you are multiplying, put this up. Okay, so if you're multiplying exponents of the same base, so if your base number is the same, then a shortcut is you can simply add those exponents together. So if I've got x to some power times x to some power, that can be rewritten as a singular x to the sum of those powers. This is a big one. This pops up all the time. This is kind of like the focus of this particular unit or this particular section. 5.1 is a lot about multiplying exponents of the same base. All right, so I'm going to do a couple of examples, then we've got a couple more properties to talk about, but I just want to start illustrating what some of these things look like. So in actuality, they're going to give you something like okay, so 5 x to the second y to the third times 2 x to the third y to the fourth, something like that. Okay, and they're typically going to give you instructions like just simplify. Okay, this doesn't, like there's no equal sign. This is not an equation. This is just an expression. So all we can do is try to combine what we can combine. Okay, so one thing to remember is this is a multiplication problem. And remember, base numbers and exponents play differently. Okay, they have a different set of rules. If I just told you to take 5 times 2, okay, that's just 10. You can multiply base numbers together. But whenever we're multiplying our x's, okay, so if we're taking x to the second times x to the third, okay, our shortcut is we can add those exponents together because these bases are the same. So x to the second times x to the third is really x to the fifth. Okay, same thing, y to the third times y to the fourth. Because these bases are the same, the shortcut is we can add those exponents together. I wish this wouldn't keep going out of focus. That's going to be really annoying to try and watch back later. It zoomed in crazy, and whenever, anyway, whenever my hand gets in there, it messes things up. I apologize, but I don't know how to fix it. So anyway, y to the third times y to the fourth. Again, because these bases are the same, we can add the exponents. That becomes y to the seventh. So this is the simplified form. So again, your base numbers, we just multiply them. 5 times 2 is 10. Exponents of the same base, if you're multiplying, the shortcut is to add. So that we get x to the fifth. Okay, y to the third times y to the fourth is y to the seventh. Okay, do another example. So we've got 3 x to the negative 2 y to the third times x to the negative third a to the fourth. Okay. If you don't see a number in front, it's an automatic 1. So if we multiply 3 times 1, that's going to be 3. Same basis, we can add the exponent. So x to the -2 times x to the -3. Add that, get x to the -5th. The y to the third doesn't have a base to go with it, so it just stays. Same thing for the a to the 4th. Now, one thing that you're going to have to pay attention to, and this gets people all the time, but to be considered simplified, you can't have any negative exponents. To be considered simplified, you have to have only positive exponents, and you can only have one of each base. So if I had 3x to the -2, x to the -3, if I didn't combine those, I'm not simplified yet. So I got to have 1x and 1y and one, anyway, one of each kind of base. So I don't want an x here and an x here anywhere, something like that. So to get rid of the negative exponent, what we got to remember is negatives cause it to flip. So even though you don't see a bottom, okay, this is like saying over 1. So this negative exponent gets shifted down into the bottom of the fraction. So this becomes a 3 y to the third, a to the 4th over 1, or just x to the 5th. Okay, if you want to put the 1 there, you can, but you don't have to. This is the simplified answer. Okay, so exponents of the same base, shortcut is we can add those together. So that -2 plus -3 became the -5, but you can't have negative exponents in your answer. So the negative switches from the bottom, or from the top down to the bottom. And when it switches, x to the -5th on the top becomes an x to the +5th down here. So again, this is your complete simplified answer. All right. So we've got a -2x times 4x to the third y times 3y to the -3rd. So regardless of how many things they give you to multiply, this is still all just multiplication. And again, your base numbers follow different properties than your exponents, so don't confuse those. Also, you don't have to do this, but I like to, just so I don't forget, these variables that do not have an exponent. So if you don't see an exponent, remember it's to the first power. I go ahead and write those ones in so that I don't forget, because there's a lot of people that just see that x, okay, and that x to the third, and they think they're adding 3 and then nothing. So they think that's x to the third. But remember, x to the first times x to the third is going to be an x to the 4th power. So you don't have to do it, but I like to write the ones in so that I don't forget. Okay, anyway, base numbers. We multiply -2 times 4 times 3. So -2 times 4 is -8. -8 times 3 is a -24. Okay. X's, remember, if we're multiplying the same base, we can add the exponent. So x times x to the third is x to the 4th. And y times y to the -3rd is y to the -2. So if we add 1 plus -3, we get that -2. Now, again, we can't have negative exponents in the problem, and it be considered simplified. The -24 is fine. Remember, this is a base number, not an exponent. So bases being negative is fine. -24, -3, whatever it is, that's fine. Exponents can't be negative. So this y to the -2, we need to flip down to the bottom. So what we get is -24 x to the fourth over y to the second. And again, if you want to have a 1 there, you can call it 1 y to the second.
Really quickly, how did you get negative 24 again?
So I multiplied my bases, so -2
Oh,
times 4 times 3. So if and order doesn't matter, but anyway, if you multiply the 3 big numbers, the base numbers, that's where that -24 came from. So if you want to go in the other way, so
got it.
times 4 is 12, 12 times -2 is still that -24, but that's where it came from.
Gotcha. The variables keep throwing me off.
Yep, yep. And that's where, like, again, when you look at just what the properties are, okay, it's all pretty straightforward, right? So it's just a 1, anything to the 0 power is 1. If we're multiplying, we add. Got it. Okay. But they throw in all this silliness and all of a sudden it gets confusing. It's like, wait a minute, what can I do? So it gets tricky. And I understand that's why a lot of what this lesson is going to be is just, it's a bunch of examples of how they use the properties. And again, this is getting recorded, so you can go back and watch it. So if you have questions or if I'm talking too fast or something isn't making sense, remember, you can go back and watch these videos. I just put them or put links to them in the Canvas class. So make sure you're checking Canvas and you can go back and rewatch any of this stuff. Or you can even like Google it. So if you want to Google properties of exponents, you can probably find a million different people explaining it in a million different ways. But maybe that would make more sense. But anyway, here's another problem that I actually kind of like. It also tends to frustrate students, but we'll do something ridiculous. Okay. And we're going to eventually get to where we could simplify something as kind of gross as this. But then if I take that whole thing and raise it to the 0 power, again, what does raising anything to the 0 power do? Just makes it 1. So it doesn't matter any of this other craziness that's going on in here. Anything being taken to the 0 power becomes a 1. I like to throw a problem like that on every once in a while, just to watch people get frustrated. I don't normally like to do that, but the people that pay attention and get free points. So anyway, that is some of your powers or properties of exponents. And then there's one more that's very similar to this one. So again, if you're multiplying exponents of the same base, you can add. If you're dividing exponents of the same base, you can subtract. So you take whatever's on the top minus whatever's on the bottom. For example, okay, so say we have something like 3x to the 4th, y to the 5th, over 6x, y to the 2nd. Okay, again, base numbers do not behave the same as exponents. These are base numbers. They follow your original rules that you learned way back in, I don't know, 3rd grade, 4th grade, whatever. Okay, so this 3/6, okay, as a fraction, we can go ahead and reduce that. 3 over 6 reduces to 1 over 2. So just like when you're multiplying your base numbers, you just go ahead and multiply those base numbers together. Same thing, we can go ahead and divide the base numbers. 3 divided by 6 is 1/2, or 1 divided by 2. Okay, also, I like to write in ones when they don't have the exponent there. And again, the shortcut for dividing exponents of the same base is to subtract. So an x to the 4th over an x to the 1st, 4 minus 1 is 3. Similarly, y to the fifth divided by y to the second. So we can subtract those exponents. 5 minus 2 is 3. So this is, again, the simplified form. One of the trickiest problems from this particular section looks like it should be really easy, but it tends to kind of confuse people. And they'll do something like this. All right, so we've got a to the fourth times a to the third times a to the negative second over a to the negative third times a. Okay, and we are told to simplify. So the good news is, hopefully you recognize that all of these bases are the same. So we're going to be able to combine this all the way into one singular a to some power. And the how and the why, there's actually a couple of different ways to do this. But what I'm going to do is I like to combine what I can on the top, combine what I can on the bottom, and then go from there. So for example, if I'm multiplying as a shortcut, I can just add those exponents together. So 4 plus 3 is 7. 7 plus negative 2 is 5. So I have an a to the fifth power on the top. Same, if I'm multiplying, I can add those exponents. Remember, if you don't see an exponent, it's a 1. So negative 3 plus 1 is negative 2. Now you can do this in a couple of different ways. So again, if you're dividing, we can subtract. So we can take 5 minus negative 2, but that's kind of confusing to me. So I take the negatives and I go ahead and flip them. So what if I have negative exponents on the top, I move them to the bottom. Or if I have a negative exponent on the bottom, I'm going to move him to the top. So this a to the negative 2 down here becomes an a to the positive 2 up here. And again, I'm multiplying, so I can simply add those exponents together. 5 plus 2, so this becomes a to the 7. You can do that in a little different order, but to me, that's the one that makes the most sense. And that's a problem you will typically see. They like to give you A's or X's or Y's, but they'll give you one variable and do a bunch of crap to it. And then it's up to you to do all the simplification. So just remember your properties. If you're multiplying, the shortcut is you can add those exponents together, combine, same. Negative exponents, we can switch. Anyway, just to show you that the order doesn't matter so much, I'm actually going to do that same problem. Okay, some people don't like to have these negative exponents. They want to get rid of them right off the bat. So they're going to move this negative exponent to the top. They're going to move this negative exponent to the bottom. Notice I don't touch the positive exponents. They just stay where they're at. So if we just move these, so then we get a to the fourth on the top. We have an a to the third on top, and now we're bringing another a to the third to the top. So this a to the fourth and this a to the third stay. This a to the negative third came up. Okay, this a to the first is going to stay down here, and this a to the negative 2 is going to come down. So if we combine 4 plus 3 plus 3, so this is a to the 10th. We combine 2 plus 1, this is a to the third. And again, if we're dividing, we can subtract 10 minus 3. This is still a to the 7th. So in a lot of ways, the order doesn't necessarily matter. The big thing is just make sure you follow your properties. Okay, and you're not done until you have only one of each kind of variable and no negative exponents. Another thing to pay attention to, so I forgot, they do throw some stuff in here, like okay. So if they use numbers instead of variables, okay, they're expecting a singular number answer. So we need to be able to reduce this all the way down. We can't reduce our variables all the way down because we don't know what A is. If we knew what A was, we could go ahead and take it to the 7th power and that would be our answer. Now, in this case, we do know what 3 is. So you can do this in one of 3 ways. Okay. Way number 1 is we can still follow our properties of exponents. So if we're multiplying, remember we can add our exponents together. So 3 to the -4th times 3 to the 7th would be 3 to the 3rd power. Then if we go ahead and take 3 to the 3rd power, that means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So that's what we're getting. Or we could go ahead and work these out. For example, if I type in 3 to the -4th power on my calculator, I get 1/81. If I type in 3 to the 7th power on my calculator, I get 2,187. And if I multiply 1/81 times that 2187, okay, I still get 27. That's not the way I would do it, but you can. And another thing, depending on which calculator you have, I don't know if anybody can see that. Usually it's too dark. You can kind of see it. You can type that in exactly the way it looks. So if I type in parentheses 3, my power button to the -4th, and close my parentheses, and parentheses 3, power button to the 7th, and close my parentheses. So I'm literally just typing in exactly what you see here, and then hit equals, and my calculator gives me the right answer of 27. So when you're just dealing with numbers, as long as you know how to type it into your calculator, it will totally do that for you. I know it's really dark. I don't know. Hopefully you can see that. I can kind of barely see it on my screen. But if you can type that in, if you're just dealing with numbers, no letters, no X's, no Y's, no A's, okay, you can just type that in exactly the way it looks into your calculator, parentheses and all. So make sure you type it in just like that.
So for showing work purposes, wouldn't the 3 to the -4th power and the 3 to the 7th power, wouldn't that basically equal 9 to the 3rd power? And that would still get you 27, correct?
No. Okay, so don't multiply those 3s. So just like when we combined all of our A's, A didn't change. It just stayed A. So same thing, even though this is a 3, because it's going to the power, okay, I'm not multiplying those together. So don't confuse that. So 3 to the -4th times 3 to the 7th is 3 to the 3rd, not 9 to the 3rd. Okay.
Okay.
So I don't want to confuse you. Going back to say a problem like this, I multiplied the 5 and the 2 together because they didn't have powers. Like I'm not combining powers. For example, if I had 5 to the 2nd times 2 to the 2nd, I can't combine those to 10 to the 4th because these two bases are different. Now I can take 5 to the 2nd power, which is 25, times 2 to the 2nd power, which is 4, and get 100. Okay, but if I did 5 times 2 is 10 to the 4th power, that's not 100. Okay, so the powers of exponents only work if the bases are the same. So this 3 to the 4th times 3 to the, or 3 to the negative 4th times 3 to the 7th, if you're going to use the properties of exponents to combine those, it stays as a 3. Does that make sense?
Yes.
Okay. That was a good question. And again, that's something where I didn't want you to get got. Okay, so just like if I combine all of my A's, my A doesn't change. If I'm using my properties of exponents to combine this into one thing first, okay, my 3 doesn't change. It doesn't change until I take it to the power. All right. I'm going to quickly change gears because there's one other topic in 5.1 called scientific notation. And scientific notation is used to write really, really big numbers or really, really small numbers. So you're going to need to be able to switch from scientific to regular notation or from regular back to scientific. But anyway, they just give you like 4 problems. It's not a gigantic deal, but the problem is, okay, so when you're dealing with large numbers and tons of calculation, okay, if you had to do a bunch of manipulations with this, nobody wants to have to type in all of these numbers. And it would be really easy to accidentally forget a 0. And if you're sending somebody to the moon and you're off by 10, they're not going to the moon. You're just blasting them off into space. It's kind of a big deal. Okay, so they came up with a way to make sure, basically to shorten how to write this. So the way scientific notation works, the rules are, okay, in a regular number, the decimal point's at the end. Okay, every number has a decimal point. You just don't always see it because we don't have anything going on out here. So we just leave the decimal point off. But every number has a decimal point. To write a number in scientific notation, we only want one number to the left of that decimal. So what we're going to do is we're going to move the decimal all the way over to here. So whatever this is, 51 billion, okay? We move the decimal point to here, and then we write this as times 10 to the power of however many times we moved it. So we moved our decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So our decimal started at the end. We moved it 10 places to get to here. So this is 5.1 times 10 to the 10th power. Okay, it's basically just a shorter way to write the number without having to deal with all of the zeros.
Is it always times 10?
Always times 10.
Okay.
All right, something ridiculous. I don't even want to try and guess what this number would be. Okay, so 3, 4, 2, 9, and then a crap ton of zeros. Okay, for scientific notation, again, we want to move the decimal from the end where it's at all the way to here. Okay, we always want one number to the left of the decimal. And we go ahead and write out the numbers that are not the zeros. Okay, when you get into certain science classes, you can talk about significant digits and when you can truncate it or whatever. For this class, basically anything that's not your zeros, we're going to include it. And this is going to be times 10 to some power. And that's going to be however many places we moved our decimal. So we've moved, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 places. Going in the other direction, So say I had 4.103 times 10 to the 5th power. Okay, then my decimal is going to move in the other direction this many places. So we're going to go from where it was. Okay. And we moved 1, 2, 3, 4, 5 places. So that would be 410,300. So you should be able to go in both directions. If they give you some gigantor number, you should be able to write it in what we call scientific notation. If they give you scientific notation, you should be able to rewrite that as the gigantor number. Now, scientific notation also works for small numbers. So if you're talking about things that are like microscopic, so something like 0.0000, whatever, 3, 4, 2, somethings. Okay, so just like we can do big numbers, scientific notation uses positive exponents. When you have really small numbers or something, so to the right of the decimal point, okay, this becomes 3.42. So again, we want to move our decimal to where there's only one place to the left of it. So we're going to move it to here. It's still times 10. 1, 2, 3, 4, 5, 6, 7, 8 places, but we say that's to the -8th power. So with a really small decimal, okay, it still moves until there's one number left of the decimal. Okay, just it's a negative exponent. Okay, again, going in the other direction, if I give you a scientific notation problem, so say 1.13 times 10 to the -7. Okay, that's 113. My decimal was here. I got to move 7 places to here. So 1, 2, 3, 4, 5, 6, 7. That becomes 0.000000113. Now, again, don't let the exponent fool you with the base. So if the very first, oh man, come on, focus. Okay, the very first number I did was like 51 billion. If this would have been a negative 51 billion, okay, that just makes this number negative. That doesn't change my exponent. Okay, so if my if my zeros are to the right, like a gigantor number, okay, then I have a positive exponent, even if the number is negative, right? Okay, same. This 0.000000342, if this would have been negative, okay, that just makes this number negative. What makes the exponent negative is the fact that it was a really small decimal number. Okay, so don't let a negative in front of the number fool you. That doesn't change anything but the number. Okay, it doesn't change your exponent. And there's not many problems. There's just like a couple in your homework. That's another thing I wanted to talk about, and I'm kind of sorry, but chapter 5, the homeworks are kind of big. I think pretty much all of them have anywhere from 15 to 16 problems. So it's a bunch of different examples of doing a lot of the same kind of stuff. They each throw a little bit different curveballs in there, but anyway, so when you go to do your homework, just understand that there's going to be quite a few problems. Make sure you're giving yourself plenty of time. Also, make sure you're staying on top of that homework. From the first exam, most of you did really well, but there were just a few people that I can tell you either forgot to do an assignment or you just ran out of time or whatever. So anyway, try to do your best to stay on top of your homework. You want to get all the points that you can get. Points are good. Questions on scientific notation? Okay. 5.2 is still dealing with properties of exponents. There's just another one, another couple actually. If you're taking a power to a power Okay, the shortcut is to multiply those powers together. Okay, so if I was taking 2 to the third power to the second power, okay, as a shortcut, we can just multiply those exponents together. So 2 to the third to the second is like saying 2 to the sixth. So 2 times 2, 6 times is 64. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Times 2 is 32. Times 2 is 64. Okay, another way to think about that is, okay, 2 to the third power, 2 times 2 times 2 is 8. And 8 to the second power is 8 times 8, which is still 64. So anyway, if you're taking a power to a power, you can multiply. If you're taking a product to a power, that power applies to both. And similarly, if you're taking a quotient to a power, again, that power applies to both. Again, the concept is simple. The application gets a little bit tricky. For example, if I told you to take 2x to the third power, okay, what this means is, okay, I'm taking 2 to the third power, and I'm taking that x to the third power. So again, that power applies to both. So 2 to the third power, 2 times 2 times 2 is 8. And taking a power to a power, I multiply. So that would be x to the 9th. Okay. Most people don't have any problem with remembering, okay, multiply those powers together, that's x to the 9th. Most people forget to do the same thing and take the 2 to that third power. A lot of people will write this as 2x to the 9th. Okay, you're going to miss that point because remember, you got to take 2 to the third power as well. This power goes to whatever's going on inside because this is multiplying, okay, just like the property. You have a product, that power applies to everything inside. Same, this cubed power goes to the 2 and to the x to the third. Okay. Like I said, the concept of exponents and the properties are pretty simple, but the application gets a little wonky. There's a lot of stuff going on here. Okay. There's a couple of different ways to do this. What I try to do, I want to deal with smaller numbers, the smallest numbers possible. So I'm going to try and combine / simplify anything inside of the parentheses that I can. Okay. For example, the big numbers, so 5 divided by 2, that doesn't really simplify. You just get 5 halves. Okay. But remember, if I have exponents of the same base, I can do something. Okay, so this x is really an x to the first. And remember, if I'm dividing, I can subtract. So 3 minus 1 is an x to the second power. Okay, same thing. If I have a negative exponent, I can move it down here to the bottom. So that y to the negative 2, I'm going to move down here. And then remember, if I'm multiplying, I can add. So y to the fourth times y to the second is y to the sixth. So I want to simplify what's inside of the parentheses first, if possible. Okay, now I'm going to take everything to that third power. So 5 to the third power is 5 times 5 times 5, which is 125. And then x to the second to the third. Remember, the shortcut is to multiply those exponents together. And that is x to the sixth. Okay, I'm also going to take that 2 to the third power. So 2 times 2 times 2 is 8. And then y to the sixth, power to a power, you multiply those. So that would be y to the 18th. So that's the simplified version. Okay. Now, I'm doing examples, and I'm trying to do some easy ones and trying to do most of the hard ones just because you'll have lots of examples to have to do whenever you get to the homework. To me, one of the hardest problems, there's two I want to look at. So one of the most difficult is they'll give you something like this. So that's a 5, x to the negative third, y to the second, all to the negative 2 power, and 3x, y to the second, all to the third power. Now with this one, we really kind of got to follow our order of operations. So we've got to do what's inside of the parentheses. There's nothing we can simplify because I don't have any of the same variables. Okay, I can't really do anything with this. So I've got to take this whole thing to this negative 2 power. So 5 to the negative 2 power, remember a negative sends it to the bottom. So that becomes 1 over 5 to the second power. Okay, power to a power we multiply. So negative 3 times negative 2 is an x to the sixth. Power to a power we multiply. So 2 times negative 2 is negative 4. So that comes down here to the bottom. And then I'm going to go ahead and do, okay, 5 to the second power is 25. All right, times, so again, number to a power. So 3 to the third power is 3 times 3 times 3. That's 27. That's an x to the first. Power to a power we multiply. Y to the second, power to a power we multiply. And I'm going to put that over 1. I don't necessarily see this as a fraction, but because I'm dealing with a fraction here, I'm going to go ahead and make this one a fraction. So you can put it over 1.
Do you want us to do that on the homework or on the test?
I'm not necessarily, like you can just leave it as 27, but we got to go ahead and simplify this. And to me, it's easier to stay, so I keep things lined up. So this is a fraction where I've got something on top and something on bottom. This was just numbers on top. So I just wanted to remind myself that there's still a bottom. So I got to keep everything in line, because when you multiply fractions, you multiply straight across. So 1 times 27 is 27. And then my x's I can combine. So remember, when we're multiplying, we can add those exponents. So x to the 6th times x to the 3rd is x to the 9th. $25 times 1 is just 25. And then I've got a y to the 4th. Now, if I just look at 27 25ths, it looks like I should be able to do something, but there's actually nothing I can divide out of both of those. So that's simplified. I just have the 1x, so that's simplified, but I've got 2 y's. So I need to combine those. Remember, if I'm dividing, I can subtract. So I get 27 x to the 9th, y to the 2nd over 25. Again, this is, to me, one of the trickiest problems, because there's so much stuff going on. It is really, really easy to make 1 or 2 or 3 silly mistakes. Okay? It is really easy to forget to take the number to the power, or it's really easy to forget, okay, when you take the power to a power and it becomes a negative, that it needs to go to the bottom. Or it's really easy to forget that, when you take a power to a power, that you multiply those together. A lot of people will accidentally put that as a y to the 5th instead of multiplying 2 times 3 and get a y to the 6th. Okay. I've done this for a long time, so I make it look easier than it is. I know whenever you guys are looking at problems like on your homework or on the test, you just kind of stare at it. It's like, oh crap, what do I do here? Okay. And it gets really confusing. So just take your time and remember your properties. To me, again, this is one of the trickiest ones, just because there's so much stuff going on. And the negative exponents, to me, make things really tricky, just because people aren't used to having to switch things from top to bottom or from bottom to top. Another one of the trickiest types of problems is one like this. Okay, for all of the exact same reasons. There is a lot of stuff going on here. And there are a bunch of different ways you can go about doing this. Okay, the order of operations doesn't necessarily hold. You can do a bunch of things in different orders and still get the right answer. So again, I'm just going to kind of show you the way I would do this, what makes the most sense to me. Again, anytime I have a bunch of stuff going on inside of parentheses, I want to try and get rid of as much stuff as possible. I want to simplify whatever I can as much as possible. So my parentheses to the negative 3rd power, I'm just going to keep that. And I'm going to try and simplify, combine, condense any of this stuff that I can. So first off, that 27 ninths as a fraction. So if I ignore all my variables over here, if I just look at 27 ninths, if I gave you that fraction, you should be like, oh, wait a minute, that reduces. Okay, 27 divided by 9 is just 3. Or 3 over 1. If you want to put the 1 down here, you don't have to, but you can. Okay, I see this negative exponent, so I want to bring him down to x to the 3rd, and I've got another x here. So remember, if I'm multiplying, I can simply add those exponents. So this x to the negative 3rd comes down here. 4 plus 3 is an x to the 7th. Okay, remember, if you don't see an exponent, it's a 1. With my y's, if I'm dividing, I can subtract. So 4 minus 1 is y to the 3rd. That z is to the first, and same thing, this z to the negative exponent, I'm going to move him up. So z to the first times z to the third. Remember, if you're multiplying, you can add, so that becomes a z to the fourth. So I want to try and simplify inside of the parentheses first, but remember, you got to keep this to the negative power. Okay, next, if you have a giant pile of stuff all being taken to this power, that power applies to everything. So that 3 is going to the negative third. That y to the third is going to the negative third. Remember, power to a power, we multiply. So that's a y to the negative 9. That z to the fourth is to the negative third. So a power to a power, we multiply. So that's z to the negative 12. And that x to the seventh is going to the negative third. So that's x to the negative 21. And again, now all of those negative exponents are going to flip. So this one goes up. These all come down. So that x to the negative 21 goes to the top. That y to the negative 9 comes down. That z to the negative 12 comes down. And that 3 to the negative third comes down. But I'm going to go ahead and do that. So 3 to the third power is 3 times 3 times 3, or 27. But that negative exponent sends it to the bottom. So this is what it should look like when it's all said and done. And again, if you wanted that 1 in front, you can have it, but it's not necessary. 1 to any power is still just going to be 1. 1 times 1 times 1 is still just 1. So anyway, like I said, this one and the one that I just showed you are the hardest problems, I think, on the whole test, as far as I'm concerned, just because there are so many things going on. It is so easy to make a little mistake, and every little thing matters. A problem like this is going to be worth probably 4 points. Okay, the whole number piece is a point, the x is a point, the y is a point, and the z is a point. And if you mess up one little thing, you're throwing points away. So there's lots of little things going on. Okay, I'm going to do one more example. I said we're going to do 5-1, 5-2, and 5-3. We only have like 10 minutes left or whatever, so we'll just kind of finish with 5-1 and 5-2, and I'll adjust the timing spacing of it all, so it'll be all right. But we're just going to cover 5-1 and 5-2 tonight. Okay, so the last problem I want to look at, and this is again one that I saw similar to your homework. So say we've got 4x to the second over y to the second to the third times 4x to the second over y to the negative 1. And again, they like to take all the properties and throw them into one problem and expect you just to get it. It's like, oh my goodness, there's so much going on here. Okay, so anytime you have, again, parentheses to an exponent, we got to take care of this. If there was stuff to simplify inside, I would. I can't do anything with the 4. I only have 1x, I only have 1y, so I can't simplify inside. So what I got to do is I just got to take everything to the third power. So 4 to the third power is, again, 4 times 4 times 4. That's 64. Power to a power, we multiply. Power to a power, we multiply. So that becomes 64 x to the 6th power over y to the 6th power. Same, I would try to simplify anything inside of the exponents I could. I just have a 4, an x, and a y. I don't have anything I can combine. So I've just got to take everything to that -1 power. And instead of writing it all down, I'm going to go ahead and do the switching, because anything to the negative power switches. So this 4 to the -1 sends it to the bottom. that's 4 to the first power. 2 times -1 is -2. So again, that -2 sends it to the bottom. You don't see a power, it's a 1. 1 times -1 is -1. So that y to the -1 gets shifted up to the top. So a negative exponent outside of your parentheses basically flips everything inside. Anyway, so we've got 64, x to the 6th, y to the 1st, over 4, x to the 2nd, y to the 6th. And order doesn't really matter, but I'd like the whole numbers being to the front. Then I do the letters in alphabetic order. Order doesn't really matter, but it helps you to see, when you've got things that are the same and you need to cancel. So 64 fourths reduces. Those are both divisible by 4. 64 divided by 4 is just 16, or 16 over 1. Remember, if we're dividing exponents, we can subtract. 6 minus 2 is x to the 4th. Dividing, we can subtract. 1 minus 6 is -5. That just means that y to the 5th is here on the bottom. So again, this is the simplified form. Okay, so that's 5.1 and 5.2. Again, the properties are nothing too crazy, at least in my mind. Okay, if you don't see a number to a power, that power is 1. Anything to the 0 power is a 1. Negative exponents cause things to switch from the bottom to the top or the top to the bottom. Multiplying exponents of the same base, we add. Dividing exponents of the same base, we subtract. Power to a power, we multiply. If you have a quantity to a power, it applies to everything inside. When you look at the properties individually, yeah, sure, no big deal. Then they give you something that looks like this, and it's like, holy crap, that's a lot of stuff to have to do. So anyway, take your time, really focus and pay attention. Try not to make any silly mistakes. And then next Thursday, we'll move on. Next Thursday, we'll cover at least 5.3 and 5.4. Hopefully we'll get all the way to 5.5. But like I said, I'll adjust the schedule and I'll let you know what we're going to be covering. Also, expect your test scores either tomorrow or the next day. So I will again email you specifically what scores you have. Anyway, if you're curious just what your grade is, that's in Canvas already. So that's what I've got. It's 8:06, so you guys get out of here a couple minutes early. Anyway, if you wanted to stick around, I know a couple people had questions for me. I'm going to stop recording though. If you have any questions, you can ask them. If not, I'll see you guys next Thursday.
Okay, so the math homework I'm showing in my math lab for all of unit 5 is going to